Hello everyone, welcome to my YouTube channel School of Chemistry. So today we are going to study further the method of preparation of haloalkanes and haloarenes. Today we are going to study that how do we can prepare haloalkanes from hydrocarbons. So today's major concern is preparation of haloalkanes from hydrocarbons. In hydrocarbons, we are having aliphatic and aromatic, both type of hydrocarbon. In aliphatic, we are first having alkanes. So alkanes, we can just have the photochemical halogenation of alkanes, like we have studied earlier from class 10 onwards, that when CH4 in the gaseous state, it reacts with the chlorine gas in presence of sunlight, H nu, we represented with H nu. It lead to the formation of replacement of an hydrogen with chlorine and the formation of HCl gas. Okay, and the reaction doesn't stop at this step. It continues till all the hydrogen present in this methane are being replaced with the chlorine and ultimately lead to the formation of carbon tetrachloride plus HCl as the side product. Okay, now if we have, suppose, a hydrocarbon having 3 carbon atoms and we are doing monochlorination to it in the gaseous state in presence of sunlight. Now, where do this chlorine is going to attach? Whether it's going to attach on this terminal or on the central carbon atom. So as we can see in the above reactions that this reaction occur in presence of sunlight. So they follow free radical mechanism. And in this case, we can have 2 free radicals can be formed. One could be a secondary free radical and the other could be the primary free radical. So this is the secondary free radical, 2 degree, and this one is the primary free radical. Now, as we know, our secondary free radicals are more stable as compared to the primary free radicals. So that's why the major product formed in this reaction when we have the monochlorination of this propane, then this chlorine is going to attach at the central carbon atom. This will be our major product. This will be the major product which is supposed to be formed in the reaction. Fine. So this is a method of preparation of haloalkane from alkanes. Next, from alkenes. Now, as we know, alkenes show addition reaction. So whenever we add any halogen directly to an alkene, it also leads to the formation of haloalkane. Like we have studied earlier about bromine water test. Bromine water, when we add into any alkene, it leads to the formation, or you can say have an unsaturation test. That is, this bromine is reddish brown in color. Reddish brown in color. And its color get discharged or it become colorless when it is added to an alkene or unsaturated hydrocarbon having multiple bonds in them. So the compound this compound formed is colorless. So this test can be also used to detect whether a compound is saturated or unsaturated. Now, in the above example, I have taken a symmetrical alkene. Instead of a symmetrical alkene, I can also take an unsymmetric alkene also, like this propene. And if I am going to add bromine to this, then also the reddish brown color of this bromine get discharged and a vicinal dihalide is formed. Vicinal dihalide means when the halogen atom is present on the adjacent carbon atom. So such hydrocarbons, we call them as a vicinal dihalides. And this compound will be again colorless. We can also add halogen halides to the alkenes. For example, in this we can also add HBr. So as it's a symmetrical alkene, so we can add HBr randomly, whatever we want. That bromine could be attached to either of the carbon atom and hydrogen to the other carbon atom. But if we have an unsymmetric alkene like this, like you can say propene is there, and that you are adding HBr to it. Okay, then the addition is governed by Markovnikov rule. Markovnikov's addition or Markovnikov's rule. What does this Markovnikov's rule suggest? It tells us that whenever we are adding a reagent to an unsymmetrical alkene, then we have two parts in it. One is the positive part, other is the negative part. Then the negative part of that reagent get attached to that carbon which is having lesser number of hydrogen atoms. Now, some of the students are confused that which of the hydrogen atom is having lesser, or which of the carbon atom is having lesser hydrogen atom. So in this, we have to only look for the carbon atom which are linked to each other with the multiple bond. Okay, so this carbon atom having only one hydrogen atom, whereas the other one is having two hydrogen atoms. So we will have the product as CH3, CH, Br, and CH3. The same addition, if takes place in presence of a peroxide, plus HBr in presence of peroxide, then this will be governed by anti-Markovnikov addition. Anti-Markovnikov addition. According to which we will have the halogen atom on the carbon having greater number of hydrogen atoms. To know about the major product formed in these reactions, that why such type of products are formed in these reactions, we have to go for their mechanism. Okay, and in studying the mechanism of these reactions, we will come to know about that why this bromine is getting attached on the central carbon atom in the above reaction, whereas it's getting attached at the terminal carbon atom in the lower one. Fine. And these are simply, you can remember it by knowing it that the reaction is taking place either in the presence of peroxide or in the absence of peroxide. If the reaction is taking place in the absence of peroxide, it will follow Markovnikov addition. And if any peroxide is present in the reaction, then it have to follow anti-Markovnikov addition. Next comes the alkynes. Alkynes have triple bond in them. So they also show addition reaction, that with the bromine water. If we add bromine to them, they also change the reddish brown color of bromine to colorless first, leading to the formation of a double bond. After that, we can add one more bromine atom or one more bromine molecule to this compound, leading to the formation of an alkane having two bromine atoms on each carbon atom. If we have an unsymmetric alkyne, like we have CH3C triple bond CH, we can also add bromine to this. This also shows you an addition reaction having bromine. First leading to the formation of alkene, and in the second step Br2 is added. It leads to the formation of an alkane with two bromine atoms on each carbon atom. We can also add reagents like HBr to alkynes. If we add HBr to ethine, first this will be added randomly because the molecule is symmetrical, leading to the formation of an alkene with unsymmetric number of hydrogen atoms on both the carbon atom. So in the second step, when we again add HBr to this will follow Markovnikov addition. And if we have an unsymmetric alkyne with different number of hydrogen atoms, the addition is followed by Markovnikov addition from the first step onwards, leading to the formation of an addition product. Again, when we add HBr to this, again this will follow Markovnikov addition. This was about the addition reaction of alkynes. Now comes the aromatic hydrocarbon. That's the D part. In case of aromatic hydrocarbon, we have two methods for the preparation of haloarenes. So first one is the nuclear addition. Nuclear addition actually involves the addition of, you can say, halogen to the benzene ring when halogen is added to it in presence of anhydrous AlCl3, then one of the hydrogen get replaced with that of the halogen. And second one is the side chain substitution, side chain substitution, in which we can react a substituted benzene molecule like toluene with the halogen like chlorine in presence of sunlight. This reaction takes place in presence of sunlight. So what happens? It doesn't substitute the hydrogen present on the benzene ring, whereas it substitutes the hydrogen atom present on the side group, that is CH3. So these are the methods of preparation of haloalkanes and haloarenes from hydrocarbons. Let us recapitulate. We have started from alkanes, that is when we react alkanes with chlorine in presence of sunlight, then photochemical substitution is taking place in which your hydrogen is getting substituted with the halogen atom. If we take a propane, then the reaction is followed by free radical mechanism leading to the formation of the most stable free radical, which is the secondary free radical. So if we do monochlorination of propane, then the chlorine atom will be substituted at the central carbon. Then comes the alkenes. Alkenes shows the addition reaction when any halogen is added to them, like that of the bromine water. When we add bromine to any alkene, then unsaturation test is also given. So bromine gets added, leading to the formation of haloalkanes. If we add the reagents like HBr or halogen acids to alkenes, then also this shows the addition reaction. But if we take an unsymmetrical alkene, then the addition is governed by Markovnikov addition. And if the reaction is taking place in presence of a peroxide, then the reaction is governed by anti-Markovnikov addition. Please make a note of a point in the anti-Markovnikov addition that this reaction is only shown by HBr. So let me mark a star over here that this is only shown by HBr, not shown by HF, not shown by HCl, not shown by HI. And they will have different reasons for it. That when you will study about the mechanism of this reaction, then both the steps of this reaction, that is a reaction of HBr with an alkene, are exothermic, whereas in case of HF, HBr or HI, either one of the reaction or both the reaction are endothermic. So the reactions are not feasible, but both the steps in case of HBr are exothermic, so the reaction takes place very easily. Then comes the alkynes. Alkynes also show the addition reaction with halogens leading to the formation of haloalkanes. Unsymmetrical alkenes are governed by again and Markovnikov reaction. Okay, and we can also add the reagents like HBr, HCl to them also. And again, the reaction is governed by Markovnikov addition. Then comes the aromatic hydrocarbons. Aromatic hydrocarbons can be converted into haloarenes by two methods. One is the nuclear addition or substitution, we can say, rather than addition. It's better to say substitution. As the hydrogen atom of the benzene ring is getting substituted over here. So instead of addition, if we write substitution, that will be much better. So chlorine atom is substituting the hydrogen atom of the benzene. As the substitution is taking place at the core of the benzene ring, we call it as a nuclear substitution. If we have some side groups attached on the benzene ring, then also we can do the substitution. In that case, we have to react the halogen in presence of sunlight. So no substitution will take place at the benzene ring. Only the side group having hydrogen atom, the hydrogen atom of the side group get replaced with the halogen. So these are the methods of preparation of haloalkanes and haloarenes from hydrocarbons. Hope it helps you. So please, if you like my videos, subscribe to my YouTube channel, School of Chemistry. Thank you.